Hello everyone. Good evening to all. Good evening. Good evening to everyone. Hello everyone. This is Philippi from pantechelearning, and I welcome you all for engage your learning experience with pantechelearning anytime, anywhere, and any places. We are always supporting to the students in a technical way. What is our main vision? We are going to help 10 million students to learn the technical knowledge by the easy way. And I welcome you all to today's session of Machine Learning Masterclass. In this particular session, we are going to discussing about a regression problem based project we are going to discuss. Actually, we entered the regression problem, right? So we were discussing about the two different projects, that is electricity price prediction and also the car price prediction. These all are the things we discussed yesterday, past days. So here, this is the regression problem. That means how much and how many like that the output will become. So it is not a classification problem. So when you are going to enter the supervised machine learning in the sense, that will be classified into the two different types. One is the classification problems, and also another one is the regression problem. So now we are going to discussing about the regression problem. So regression problem is nothing but the output will be comes how many is, and also how much and how many is. So today we are going to discussing about house price prediction by using the machine learning technology. As we discussed past days classes electricity price prediction, car price prediction, the same similar procedure we are going to follow. Okay, based on the certain criteria set, based on the certain features, the house price will be predicted. For example, you should consider nowadays the real estate industries are growing very well. Okay, growing very well. Why? Because of for example, you want to buy one particular land in the sense based on the certain features, the price will be increased. For example, the land is located in urban areas or city areas in the sense, the price will be completely different from the rural areas. When I am going to coming into the rural area in the sense, that time also the price will be completely different from the urban area. Based on the criteria, based on the location. That's very important. If it is located in the main area, in the sense, the price will be vary when compared to others. But these industries increasing your growth is very well. Okay, so that time when you are going to finding the prediction of this particular location prices or land prices in the sense, you are going to finding the one particular expert, but that is not needed. When you are going to getting into the what is the technologies in the sense, the technology will predict the prices based on the area, that can be possible action. So that's why we are going to prefer, we are going to using the advanced technology right now, not going, we are going to using the traditional technologies as well. So here we are going to using the machine learning technology with the help of the XGBoost algorithm we are going to use today. Okay, that is also one kind of the regression, right? So what exactly, without delay, I am going to enter in the topic. The introduction of house price prediction. We all have an experience at a time when we looking up to the new houses to buy. For example, we are going to seeking urban areas. In the sense, based on the area, the price will be vary. It is interior or outerior in the sense, the price will be vary based on the certain features. When the journey will begin, a lot of frauds and also the negotiating deals and researching local areas and so on like that. So this kind of the problem will solve with the help of this particular technology, because of when you are going to feeding the data. For example, location and nearby areas, you want to one particular urban area is in the main road, like that, and the price will be vary and it will be predicted how much price will be in the sense. So deals with the kind of this particular issues today, we will be preparing the machine learning based model that will be giving the solution to predict the prices of that particular areas based on the areas. That's why I mentioned here. Now researching the local areas and so on. When I am going to prefer to buying the house, buying the land, we need to deal with that. This kind of the issues now we are facing. But we will be using to preparing the machine learning model in the sense, it will be help to predict whether based on the areas, it will be giving this much of price. The land is also. Okay, right. So what is our main objective of this particular project? So in this particular project, we are going to build a model for house price prediction. We are going to build a model for house price prediction based on the data features. Based on the data features from the house data set. Here we will be using the XGBoost regression algorithm. Okay, I will be explaining how it is work and what is the meaning of these particular things. Okay, so what is our main objective of this particular project? This particular project, we are going to build a model for house price prediction based on the data features from the house data set. For example, you want to buy one particular main area. So nearby schools, nearby banks, nearby bus stand, anything you have from that particular location in the sense the price will be very high, unimaginable price. If it is in the rural areas in the sense that is completely different, the price will be very less when compared to the urban areas. How they can decide how the land price will be increased based on the demand. That's very important. Based on the demands and also based on the location. That are the data features. Based on the demand, based on the location, the price will be predicted. So the same thing we are going to creating and training a model with the help of the past data. Okay, right. So what is the actions we are going to follow for this particular procedure, for this particular project? For example, data collection is a very important thing. Data processing. Why we need to collecting the data? Because of when you are going to training a model, we need a training data, right? That time you need to collecting the data from the different sources from the different location. That's very important because of the data collection is very important. When you're collecting the data, we need to pre-processing the data. That means we need to clean the data, handling the missing values like that. After collecting and properizing the data, what should we need to do? That means test, train, splits. That means we are going to splitting the data for testing as well as the training. Once you creating the training data as well as the testing data with the help of the train test split function. So once you prepare that one in the sense you are going to creating a model with the help of one particular algorithm based on the regression problem. Here the data analyzing is very important because of our output will be how much and how many. That is not a classification problem. Try to understand that because we were discussing about the past days classes only the classification problem. Past 2 days only we are discussing about the regression problem. That means we need to analyzing the data. Based on the data, how much price will be for the house in that particular location which you have seen before. Hope you guys are understood about it. That means it is absolutely a regression problem. It is absolutely a regression problem. So once you are going to creating a model in the sense we need a XG boost algorithm. That is the regression algorithm for the prediction. So with the help of XG boost algorithm will help to creating a model. And also with the help of the training and also the X-train and also the Y-train training data set, it will be trained. Once it is trained in the sense, we are going to getting into the evaluation process. Okay, right. So once the training is completed, when you are going to feeding the new data to the trained model in the sense, it will be predicted whether the house will be this much of price on that particular location based on the data features. That's very important. So this is the new data. When you are going to passing through the XG boost, that will be predicted the house price. This is the way to the project will be run. This is the way to the project will be constructed like that. Okay, hope you guys are understood about this particular actions of machine learning. Right now, what does XGBoost regression exactly? Before entering the algorithm, if you guys are really interested to join the internship, please do join the internship. The price will be very less. It is nearly 590 rupees. The link is mentioned in the description. Use that particular link to learn more about the machine learning technology. This much of money, this much of content. We were discussing about that particular internship is many of the projects, nearly 20 projects for this 30 days on internship. So please use this opportunity. This is very special offer for you. Okay, right. Now I'm going to getting into the XGBoost regression. What is XGBoost? XGBoost is one of the robust machine learning algorithm that will be helpful for the regression problems, giving the solution for the regression problem. It will be help you to understand your data and also making the good decision. For example, the XGBoost is an implement of the gradient boost decision tree. That means, for example, what is the meaning of the ensemble learning? Ensemble in the sense we need to choose the multiple decision trees on the random forest algorithm. Okay, that particular multiple decision trees giving the results. After that we are going to getting into that is it will be help to predict the sample data output. After that we are going to getting into the averaging, that is packaging like that will be giving the good result. The same concept we are going to implement here as well. So XGBoost is an implement of gradient boosting on the decision trees. It has been used for the data scientists and also the researchers worldwide to optimizing their machine learning algorithm. It designed help to build a better model and also works by combining the different multiple decision trees and also gradient boosting. Okay, how does it actually work? You can see here decision trees, and also the random forest, and also the gradient boosting. So before explaining this one, I will be tell about this particular things. What is extreme gradient boosting? So extreme gradient boosting is a highly efficiency and also the scalable machine learning algorithm. It is used for the classification as well as the majorly regression problem. It is based on the gradient boosting. So which is train multiple decision trees. That's very important. It has trained multiple decision trees. It is similar like a random forest algorithm. So it will be trained like multiple decision trees to form a strong predictive model. After that, the strong predictive model. For example, what is that? Once you are going to selecting the random sample data to apply under multiple decision trees, tree 1, tree 2, and tree 3. These tree 1, tree 2, tree 3 will giving the one particular result, result 1, result 2, result 3. Now we are going to calculate the sum to calculating the average. After that, it will be giving the result. That means sum is very important. The final result will be giving the value of that particular which is getting from the decision trees. Okay, so the XGBoost has several advanced features such as regularization, early stopping, parallel computing, which is enhancing its performance and also the prevent the overfitting. Okay, that's very important. It will be help to avoiding the overfitting problem as well. Okay, right. So what is that exactly the extreme gradient boosting? Based on the gradient boosting and also the decision trees, you can see here it will be help to parallelized tree building and tree furnishing and the depth first approach and also awareness and output of the core computing, regularizing for the avoiding overfitting and efficient handling of machine values and also inbuilt cross validation capability. So here I will tell the technical name meanings how the XGBoost working. So what is the meaning of boosting here? The XGBoost training a series of weak decision trees and also comparing their prediction to produce the final prediction. What is that exactly? Once you the decision weak decision trees are combining their prediction value, which is the decision trees giving the one particular result. That means helpful for producing the final prediction. So what is the decision trees done? The XGBoost is used the decision trees each branches representing a prediction for the large variable. So each decision trees will giving the one particular result. Okay. So here the tree training, the XGBoost training each decision by finding the splitting in the data and reducing the loss function. It is similar to it will be more helpful for image data and also the text data. It will be majorly helpful to train. After that, the gradient descent. Okay, so here the XGBoost used for the gradient descent to update the prediction for each and every decision trees. So what is the meaning of the ensemble prediction? The XGBoost combines the prediction of multiple decision trees and it will be helped to weighted for the average of each decision trees. That means it is consist of the multiple decision trees, multiple algorithm. Most commonly, the XGBoost will help to using the multiple decision trees to applying and avoiding the overfitting, underfitting. These are the things to prevent, and it will be making the regularization like that. We are going to use and preferring the XGBoost here. So the XGBoost combines the prediction of the decision trees of the weighted average of each decision trees prediction. So what is the meaning of the early stopping? The XG prevent overfitting by the stopping training process when the performance of the model on the validation setup and stop to improving that. So for example, I will get into that. You can see here, once you're collecting the data for the house price prediction, it does a random sample going to apply on the multiple decision trees. Each decision tree is giving the one particular result. For example, decision trees result will be 1. The tree 2, that is the the output will be result 2, and also the tree will be result 3, like that. After that, it is going to be sum of each and every values because of it is a regression problem. Then finally finding the result based on this particular summation. Okay, right. So here the decision trees first initially. This is the working flow. The decision trees. A graphical representation of the possible solution to decision based certain condition. That means what? Based on the certain condition, each decision is giving the one particular result. So what is the meaning of the package? The bootstrap aggregations or packaging is an ensemble meta algorithm combining the predictions from the multiple decision trees through the majority of the voting mechanism. That is nothing but averaging. So what is random forest? It is the packaging based algorithm. It is a packaging based algorithm where only the subset of the features are selected to selected randomly to build a random forest collection decision trees. And what about the boosting? Models are built sequentially by minimizing the error. That's very important. So that's why we are going to choose this one. So once you are going to collecting the data and training the data with the help of the multiple decision trees to finally calculating the average, the boosting will help to minimizing the error to increasing the performance from the previous model while increasing the boosting and influence of the high performance of the model. Okay, what is the gradient boosting? So gradient boosting is employs the gradient descent algorithm to minimize the error to the sequential model. So what is exists? It is optimized gradient boosting algorithm through the parallel processing handling the missing values and regularization and also to avoiding the overfitting. So that's why we are going to use HG spools algorithm. Okay, right. So without delay, I'm going to entering the topic, coding about it. House price prediction. Now we need to import the necessary libraries here. Numpy, Pandas, Matplot, Seaborn, sklearn dataset will help to load in the dataset from which is from sklearn. The sklearn model selection, then importing the training, testing, splitting data, and XGBoost importing the this particular algorithm XG regressor. Because of XGB regressor, we are going to use to creating a model for this particular problem. Then sklearn import matrix. Here we are going to use to calculate the R square error value that will be fine to performance of the model. So based on the percentage of the error. So now we are going to import the house price prediction dataset. Here, house price dataset is equal to sklearn dot dataset dot load Boston. So this is nothing but the house price prediction dataset. So house price dataset is equal to the data value will be like that. So we need to making the data frame for this particular data. How we can make it actually? Just to see here. This is the target value. So this is the target value of the price prediction. So 24, 21, 34, 33 and 60. This is based on the value. Okay, right. Now we are going to making the data frame here. So house price prediction data frame is equal to pd dot data frame. Then passing the house price dataset dot data. So here is the data. And also the columns will be the features name. The features name like here. And also it is going to be making the data frame like this. So this is the features name, and also this is this is the values of this particular each and every columns. Now adding the target here to the particular data frame. So house price data frame and creating the one particular label. So here the house price dot target, and the output will be comes the price will be added at the end of the dataset. Now checking the number of rows and also the column in the data frame. So this is number of rows and number of columns, which is helpful. Help the function is dot shape function, that is 506 comma 40. That means 506 in the sense rows and 14 is the column value. Okay, this is the return for this particular function. Okay, now we are going to checking the null values. Okay, we are going to checking the null values or missing values. So how we can find it with the help of is null of dot sum of. So you can see here the value will be like this, everything will be 0. Okay, so no need to clean this particular data frame. So statistical measure of this particular data. So with the help of dot describe will help to display the count of the each and every columns and beats and standard deviations minimum and 25%, 50% and 75% and maximum range. Now we are going to find the understanding the correlation between the various features in that particular data. So how we can make it that the correlation is equal to house price data frame dot correlation of the function. This is one is the positive correlation, two is the negative correlation. Now constructing the heat map for that particular correlation. So PLD dot figure size will be the 10 comma 10. Okay, the size will be the 10 comma 10. So SNS dot heat map of the heat map to passing the correlation data. Then this will be the parameters. This is like extension 1f, the anode true. So the value will be like this, and it will be displayed. You can see here we are going to using the heat map. It will be displays the multiple colors, for example, darker color is a positive, lighter color is a negative. So this is the darker color, this is a positive, one is a positive and two is the negative. And you can see here, this is a correlation of the each and every columns. Now we are going to splitting the data. Splitting the data, that is independent data as well as the dependent data. How we can make it in the sense, we are going to store the value of independent data in X. We are going to store the value of dependent data to the Y. So house price data frame dot drop here. This column is not needed because of this is the dependent data. This is the dependent data. So we need to drop this one, and also this is a dependent data for Y. Then you can see here print X and print Y. This is the independent data and this is the dependent data. It will be displayed like that. This is the based on the data features. The output will be like this. The price will be like this. Now we are going to splitting the data into the training data as well as the testing data. That means X train, X test, Y train, and also the Y test. Don't change the position of this particular, making the training data as well as the testing data. So here X train, X test, Y train, Y test is equal to the function of train test split, then passing the independent data and also the dependent data, that is X and also the Y. The test size is equal to 0.2, that is nothing but 20% of testing and remaining 80% of training. The random state is equal to 2. The random state is equal to 2. It will be helpful, it will be help to fixing the percentage value. Once you are going to run it again and again, in the sense it will not change, it won't change the percentage of the performance of the model. So here we are going to print X dot shape will displays the 506 and also the 13 columns. This is rows and also this is column. Then this is the 80%, this is the column, this is 20%, this is the column. Okay, now we are going to getting into the training process. So XG booster regression, the model is equal to XG regression. So this is nothing but where we can get it actually from sklearn dot XG boost, then importing the XG regression, XGB regression. So model is equal to XGB regression. This is nothing but a model creation. This is nothing but the model creation. After completing the model creation, we are getting into the model training. So with the help of dot fit function, the X train, Y train. So here we need to training a model with the help of the training data. With the help of the training data, that is X train and also the Y train. So training a model with the help of the X train and also the Y train. So here the training process is completed with the help of the XGB regression. So this will be trained with the help of training data. After that, we are going to getting into the evaluation process. So we need to calculate prediction on the training data, prediction on the testing data. The accuracy score for the the accuracy for the prediction on the training data, accuracy for the prediction of testing data. So training data prediction is equal to model which you trained and call that predict function. For the X train we need to pass. So this is the prediction of X train value. Then now R squared error we need to calculate. For example, when you are going to calculating the classification problem, that time we are going to use the accuracy score function will help to display the percentage of the model, performance of the model. But here we are going to calculate the R squared score. Okay, R squared error. So based on this particular score, this is also nothing but the performance of the model. That means the score 1 is equal to matrix dot r square score to pass the white train and also the prediction of the training data. Okay, now we are going to calculate the mean absolute error. Mean absolute error. So that means you can see here the score 2 is equal to matrix dot mean absolute error of passing the same thing. So here the error will be 1.14. That performance is equal to nearly 97 percentage. That means the absolute error will be 1.14 percentage only. That means the model performed very well because of the score will be 0.97. Okay, the mean absolute error will be 1.14. Now we are going to visualize the actual prices and also the predictive prices. So PLT dot scatter function we are going to use on the training data, training prediction data. The actual prices, then predicted prices, and this is the so the scatter plotting of the training data. Now we are going to apply the prediction on the testing data, the accuracy score for the testing data. So accuracy for the prediction on testing data. Here the test data prediction is equal to model dot predict of passing the X data here. Then R square error we need to calculate. The score 1 is equal to matrix dot R square score. This is a function to returning the percentage of the performance of the model. Then we need to compare the Y test and also the test data prediction. Now we are going to calculating the mean absolute error. So this will be also nearly 2%. So here the score is equal to matrix dot mean absolute error. Then passing the Y test and also the testing data prediction we need to compare. So normally the R square error will be 0.91. But the mean absolute error will be 1.99. That means this is this is also that for the training data, this is also giving the 91 percentage of the performance is very well. The accuracy score will be nearly 91 percentage. Mean absolute error will be 1.99. Okay, so this is the way. Okay, this is the way we can creating the model and finding the performance of the model. That is nothing but evaluation process. Evaluation process. Once you trained in this, when you are going to feeding the new data to the system, it will be predicted the house price prediction. Okay, hope you guys are understood about it. So the same procedure for the regression problem. Okay, hope you guys are understood about it. Now I am going to getting into the my time. So every day I mentioning one particular motivational quotes to you. When you are going to read this, it will be moving towards the positive level. Okay, right. So this particular motivational quote. It is not to you only. It is not for, it is for me as well. Okay, right. Just breathe. Today's motivational. Just breathe. You are strong enough to handle the challenges. You are very strong enough to handling your challenges and enough to find the solution of your problem. And also capable enough to do the whatever you need to be done. So just believe it. Just believe it. Don't let it down yourself. Don't let it down yourself. And don't towards to down. Please make your life will be rise. Just breathe. You're strong enough to handle your challenges. Wise enough to find the solution to your performance, to your problem. And capable enough to do whatever need to be done for you. You are eligible. Don't be complexive. Don't be complexive. Because all the things you can do, just breathe. You are enough mature to handling the challenges. You are enough mature to finding the solution for your problem. And also you are very capable to whatever need to do done for you. Okay. So you are complete package to whatever do for your life. Okay, move towards a positive, do with a positive thing and believe yourself. That's very important. Just breathe and believe yourself. All the things can be done by you only. No one cannot no one will help you. No one will help you. You only responsible for your problem. You only respond for your challenges. You only responsible for what you need to do. Okay, so keep it in your mind. Keep your life in a positive way. Okay, right. I hope you guys are understood about the today's concepts. I hope house price prediction, that is a regression problem based. Explore your knowledge with us anytime, anywhere, and any places. We are always here for you to support you. We are always here for you to support you in a technical way. Thank you so much. Be with a positive and live with the positive things. And also believe yourself. You can do all the things for your life. Okay? Right. Thank you so much. Explore your knowledge with us anytime, anywhere, and any places. Thank you so much. We'll meet you with a different topic in next video. Bye bye.